Okay, this lesson's on multiplying a polynomial by a constant symbolically. The beginning of this lesson is intended to look very similar to the beginning of the last lesson. When we multiply a polynomial by a constant, whether we're using algebra tiles or we're doing it symbolically, we are making copies of a polynomial. So the difference being is that if we have 3 times 2a plus 5 and we're not using algebra tiles, then we just go ahead and take the polynomial 2a plus 5 and add it together 3 times, just like that. We're not drawing it out 3 times, we are writing it out 3 times because we're making 3 copies, which goes with the 3 that goes in front of the polynomial. So when we have 2a plus 5 plus 2a plus 5 plus 2a plus 5, we use the same thinking that we used when we combined our like terms. We identify our like terms, so 2a goes with 2a, goes with 2a, 5 goes with 5, goes with 5. Then we make sure to put all the 2a's together and all the 5's together, and then we just simplify. 2a plus 2a plus 2a is 6a. And 5 plus 5 plus 5 is 15. So 3 times 2a plus 5 is 6a plus 15. Now, but what if this was, I don't know, 33, not 3, 33. Do you want to write this out 33 times? No, that seems like a waste of time. So what we can also do is we can look at the number that is in front of the bracket, and we can multiply it by the first term. So that's 3 times 2a. And then we can multiply it by the second term. So that's 3 times 5. So 3 times 2 is 6a, and 3 times 5 is 15. So we could just do that. Whatever the number is in front of the bracket, multiply it by each and every term inside the bracket. Okay. So let's do some examples. Let's go ahead and do 4 times 3n cubed plus 2. So what we're going to do is we are going to take 4 and we're going to multiply it by 3n cubed. So that's 4 bracket 3n cubed plus, then we're going to take that same 4 and multiply it by 2. 4 times 2. When we multiply 4 times 3n cubed, we only look at the number, the coefficient. That's the only thing we're multiplying by 4. So what do we get when we multiply 4 by 3n cubed?
12n cubed.
Very good. 12n cubed. That's it. So nothing happens to the exponent, just stays the same. And 4 times 2 is good. So the answer is 12n cubed plus 8. That's it. All right. Question B. Negative 3 times 5 plus t. So that's going to be negative 3 times 5. The way we write it out, the second term is this. There's a plus sign here, so we're going to put a plus sign here. But then we're multiplying negative 3 times t, so we'll put the negative 3 in brackets, and we'll put the t in brackets, although the t doesn't really have to go in brackets. So what's negative 3 times 5? Negative 15. And what's negative 3 times t? Negative 3t. So we don't need to put the plus sign. We can just go minus 3t. One of the things that some students do sometimes, and I get why they do it, is sometimes we get a mess in here and we have more than one sign. If you have a mess in here and you have more than one sign, you need to clean it up and make sure that, if you have a plus and a minus, that makes a minus. If you have a minus and a minus, that makes a plus. Make sure you only have one sign here. That's question B. Here's question C. 5 times g squared minus 3g minus 4. So this is the first time we've had a trinomial inside the brackets. So it's 5 times g squared minus 5 times 3g minus 5 times 4. And we're going to work out each of those products. What do we get? What do we get?
5g squared.
Beautiful. And then? Plus or minus? Very good. And then? Excellent. 5g squared minus 15g minus 20. Fantastic. And that's all we do for that one. Question D. Question D is interesting because, well, maybe it's not that interesting. I was going to say it's interesting because there's a negative, but we already did one with a negative. I guess it's a little interesting because we have a squareds, b squareds, and ab's. But anyway, this is going to be negative 2 times a squared minus negative 2 times ab, and then plus negative 2 times b squared. All right, so first term is fairly straightforward because there's really no multiplying and there's no complication with double signs. It's just negative 2a squared. What's the next term going to be, though? Minus minus makes a 2ab, correct? Now, the next batch of signs, we have a plus and a minus, which makes a minus 2b squared. Yeah. So our integer rules that we learned at the beginning of the course come to the rescue and help us simplify those signs nicely. All right, we've got 3 more examples. These ones are like the last example the second last example we did in the last lesson, where we have some floaters. We have this 1, we have this 2q, and this -5. So we got to remember those and work with those when we work through this. So when we work through this, we're going to be taking this 3 and we're going to multiply it by each of the terms inside the bracket. But the 3 doesn't get multiplied by anything because it's lonely and it's all by itself. So the 1 is here, and then we have 3 times 2g minus 3 times 5. So because we have some terms all by themselves, we'll have some extra simplifying that needs to be done that we have not had to do yet so far in this lesson. The 1 is still 1. It's waiting for us to figure out what we get when we expand that bracket. 3 times 2g is what?
6g.
Beautiful. Good work. And there's only one sign here, so it's straightforward. What's 3 times 5? Great. Now, what we should be thinking, though, now, we got a 1. We got a -15. We need to put them together. Now, here's the thing, okay? Now that we are becoming experts at polynomials, I know that at least one of you, and maybe most of you, are thinking to yourself, do we really have to take another step and put the 1 and the -15 together? Or can we just go 1 minus 15 and get the answer? Well, right now, we're not collecting like terms. So here's what I'm going to tell you. If you want to live dangerously in math, and you want to just put the 1 and the -15 together without putting them together beside each other, go ahead. However, because this isn't too complicated, it's just 2 numbers. But sometimes you're going to be putting together 3 or 4 numbers. And when you're putting together a lot of stuff, it's going to make a lot of sense to write it out and write another step. But if you think you can do it without making a mistake, go ahead. Just be careful. So, let's try and live dangerously here then. What is 1 minus 15?
-14.
Very good. You are living on the wild side, Jacob. So we can just write 6g minus 14. Okay? That's it for question A. Now, question B, we are going to live on the wild side once more. We have -3 times 2q squared and -3 times +1. If you want, what we can do, we have the 2q here. We have the -5 here. Why don't we go ahead and just multiply -3 times 2q squared right off the hop? And if we do that, what might we get?
-6 squared.
-6.
-6q squared.
Very good. And then we're going to take that -3 and multiply by +1. What might we get when we do that?
-3.
-3. So that's what we get when we multiply the -3 by the contents of the bracket. Now, If we want to live on that wild side twice again, we can just rearrange this and go from there. Now, when we rearrange it, let's put the q squared term first, because we always write the term that has the highest degree first. So that is minus 6q squared. And there's no other term with q squared in it, so it doesn't change. It's negative 6q squared. Likewise, for the 2q. The 2q is 2q. There's nothing to combine it with. But the last two terms that we haven't chatted about quite yet are the negative 3 and the negative 5. They can be put together to give us what? Very good. And there you go. There's our answer. Now, a couple questions ago, I would have had 4 lines of work here. Here we have 2. Everybody has their own little workflow that works for them. I don't care if it takes you 2 lines of work or 12 lines of work. What's important is you understand what you're doing, you're confident with what you're doing, you're good with what you're doing, and ultimately you get the right answer. And if I look at your work, I can follow your thinking. I can always follow your thinking. I shouldn't say always. Usually follow your thinking better if you show me more work. So if you show me less work, okay, just make sure you're right. Because if you show me what you're thinking and you make a mistake, I can give you some partial credit because at least I know what you're thinking. If you just jump to the answer and you're wrong, then I'm wondering what the heck were they thinking? And if I don't know what you're thinking, well, then I can't give you any credit if you don't show me any work. So just be careful. Last question here. Here we go. This is like the last question of the last lesson. We have 2 products. And again, what we can do is do the multiplication of both. So we'll just go ahead. What's 3 times t squared? 3t squared. Yep. 3 times negative 2t is, as Jacob says, let's take away 6t. Yep. Then we're going to go and do the same thing over here. We're going to take that 2 and multiply it by both of those terms. What do we get when we do that?
2t, take away 12.
What's the sign that goes right here?
Plus.
Right. Got to make sure we just include those signs. Okay, cool. Now we can go ahead and group our like terms. So 3t squared is on an island by itself. There's no other terms with 3t squared. So that's all we got. Now we have 2 terms with t in them. If we put them together, what do we get?
Negative 4t.
Negative 4t. And negative 12 is also on an island because there's no other term that's all by its lonesome. So the answer is 3t squared minus 4t minus 12.